Good morning and welcome to day 5. Today's topic, energy effects in binary ionic compounds. All right, guys, lattice energy. Lattice energy can be described as the change in energy when gaseous ions are packed together to form an ionic solids. Now, one thing I want you guys to remember is that from the molecule's perspective, when bonds are broken, energy needs to be put in to that bond. So that would be an endothermic change. And when new bonds are formed, energy is released by the molecules, or in this case, ionic compounds, and that energy would be exothermic. Okay, so a positive change in energy means that energy is going into breaking that bond or change the state, and a negative change in energy means that energy is being released by the formation of a new bond or a phase change. Okay. All right, a couple things to look at. I realize the titles are a little bit different, but a exothermic reaction is one in which energy is released. I know we've kind of talked about it like a ball rolling down a hill. Sometimes that ball needs a little bit of a nudge. So if you have a ball up here that's at the top of a hill, it can't just roll down that hill. You kind of have to give it a little bit of a nudge. Once you get it to the point where it is ready to move, now it will spontaneously roll down that hill on its own. But generally speaking, exothermic reactions are much more likely to be spontaneous. Now, on the flip side, an endothermic reaction is one in which we're pushing something uphill. Okay, these are much less likely to be a spontaneous reaction. Realize you do get a little bit of energy out, but you have to put much more energy in than you will ever get in return. So these reactions do not tend to be spontaneous. Just remember, a reaction in which the ball rolls down the hill is much more likely to be spontaneous than one that does not. All right, so one of the things you guys are going to have to do in tonight's homework is you're going to have to do some calculations, okay? So we want to know how much energy is going to be needed in order to make lithium fluoride in this case. Now, this reaction takes 5 steps, okay? So, step 1 is, okay, think back to our definition. This takes place in a gaseous state. So step 1, we have to take solid lithium and we have to turn it into a gas. So if we look at our lattice energy definition, it's got to be in a gaseous state. So sublimation is the process of which we turn a solid into a gas. Just think about dry ice. Dry ice is a solid. When it warms up, it skips the liquid phase and turns directly into a gas. Now, in order to turn 1 mole of lithium from a solid into a gas, you have to put in 161 kilojoules of energy per mole of lithium. So that is going to be an endothermic part of the reaction. Okay, I'm going to change colors. Part 2. Now, in order to form lithium fluoride, we don't need lithium metal, we need lithium ions. So we're going to have to find the ionization energy for lithium, and the amount of energy that it takes to remove 1 electron is going to be about 520 kilojoules per mole. So we're going to have to put some energy in. We're kind of pushing it up that hill, but then hopefully it's going to roll down the other side. All right, now let's change our focus and look at fluorine. Fluorine is a molecule that's diatomic. So we don't need an entire molecule of fluorine. We only need half a molecule of fluorine, or 1 single fluorine atom. So, guys, this is something you're going to have to do in your homework tonight. You're going to have to take the dissociation energy for a molecule, and you're going to have to divide that value in half. So if I wanted to dissociate an entire mole of molecules, it would take double this, which would be around 308 kilojoules per mole. In your homework tonight, you're going to have to take that numerical value and you're going to have to divide it by 2 if it is a molecule in which you only need half of that molecule. So half a molecule of fluorine. Okay, we have to break this bond. And when we break that bond, it takes energy. That is going to be an endothermic change in which it takes about kilojoules per mole. Keep in mind, guys, the original value for that number for an entire molecule would be closer to 308, but we only need a half of a molecule or a half of a mole of fluorine, so I divided that value by 2. All right, now we're going to start to get some energy back on the flip side, okay? When fluorine gains an electron, it's got an electron affinity, so it's going to be more stable. So when a fluorine with 7 valence electrons gains an additional valence electron, it actually releases a little bit of energy. It's a more stable configuration. And now we see a negative value of 328 kilojoules per mole. And really the last step to our process is the formation of lithium fluoride. So we've already created lithium ions. We've already created fluorine ions, and when lithium positive and fluorine negative attract together, they're going to release about 1,000 kilojoules per mole. Now, last step is we need to sum these up. So the positive numbers, positive 161, positive 520, positive 154, and then we're going to subtract out the negative 328, the negative 1,047, and we get an overall negative value. Now remember, a negative value is going to be exothermic, and a negative value indicates that it's going to be spontaneous. If this value were to be positive, it's most likely going to be an unfavorable or less likely to occur on its own. Guys, I think I am going to post one more video. Just to give you one more example problem. You will have to do one in your homework. Sorry the lesson's running late, but I miss you guys. I love you guys. I hope to see you after spring break. Talk to you later.